Hi everyone. Have you ever wondered on the foundation of some applications like maps, social media sites like Facebook, or any other application that you use every day? This might surprise you, but the answer to these questions is data structures. So if you're interested to know more, then in the series of videos we'll be covering everything about data structures and their implementation in Python. Let's start with the definition of data structures. A data structure is a particular way of organizing and managing data in a computer so that it can be used effectively. To understand the need of organizing data, let's imagine a dirty room where everything is scattered here and there. Now let's say we need to find a particular item like socks. For this, we will have to search the entire room. We might start from the bed, then under the bed, then the wardrobe or the desk, etc. This is very inefficient way. This makes our item, here the socks, useless as we can't use it when needed. Now imagine the other case, a clean room where every item is kept in an organized manner. Clothes in wardrobe, books on the shelf, and so on. Now, if you need any item, you know exactly where to search. Another example we can take is of a dictionary. There are thousands of words in a dictionary. That's why they are organized in a sorted alphabetic order, otherwise you would have to search through entire pages to search just one word. Can you imagine that? This is exactly the reason why it is so important to organize our data. If we don't organize our data as per any logical structure, we might not be able to find the particular item when we need it. Nowadays, there is so much data to process. So the choice of data structure has a crucial impact on the efficiency of a software program. Thus, understanding data structure helps to reduce the space and time complexity of different tasks or operations that we perform on our data. Space complexity is the space taken by the program with respect to input size, and time complexity is the time taken by the program with respect to input size. Both space and time complexity are function of input data size. So the question that might be arising in your mind is why we calculate the time complexity or space complexity in terms of input data size and not in terms of actual storage units like byte or KB for space complexity and millisecond or second for time complexity. The reason is, if we keep complexity in terms of actual units like millisecond, then we will have to keep into consideration of the hardware of the machine on which the programs were executed, which cannot be used universally to compare two programs. For better understanding, suppose we have a poor designed program running on a machine with good hardware and an efficient program running on a machine with poor hardware. Then it might be possible that the time taken by the poor program will be less than that of an efficient program, making it better, which is wrong. So to know the efficiency of a program, we measure it in terms of input data size, which gives us result which can be accepted universally for any program. So far we have studied what is data structures and why do we need them. Next thing we need to know about is abstract data type or ADT. Whenever we talk about data structures, we combine them with the operations we perform on them. And this combination is called abstract data type. So ADT consists of two parts: declaration of data and declaration of operations. Just like when we talk about some primitive data type like integer, operations like addition, subtraction can be associated with it. It is called abstract because we only mention the operations, not how the operations will be implemented. ADT is a theoretical model, and data structures is the concrete implementation of ADT. Let's look at some examples of ADT. First, we're gonna talk about List ADT. In List ADT, data is stored in a sequential order. The data can be at continuous memory locations or at random memory locations. And the functions that can be performed on a list ADT are get, which can be used to fetch the element in the list. The other function is insert, which can be used to insert any value into the list. The insertion can be done at any position, depending on the function that we implement. Other function can be remove, to delete any element, replace, to change any existing data. This function can be used to know if the list is empty or it contains any value. This will return boolean value. Similarly, we have another function is full, which can be used to know if the list is already full or do we have space to enter new data. This also returns a boolean value. During study of ADT, we don't define functions. During implementation in a data structure, we actually implement these functions. Other example we can take is of stack ADT. In stack ADT, data is stored in a special order, which is called last in first out, or LIFO. That is, the last element inserted into the stack is the first element that gets deleted. It is similar to the stack of plates you must have seen every day. Like whenever we insert a new data, it gets placed at the top, and when we need the data, we use the same data that was inserted at the last. That is why it is called last in first out. So the functions that can be performed on a stack are push, which can be used to insert an element at one end of the stack. The end at which we can do the insertion or deletion is called the top. Other operation is pop. It is similar to delete function and it is used to remove or return the element at the top of the stack if it is not empty. Peek, which is used to view or you can say return the top element. Similarly, size, which returns the number of elements in the stack. For this example, it will return 5 because we have 5 elements. And other functions are is empty, which returns true if the stack is empty, otherwise it returns false. Also we have is full, which returns true if the stack is full, otherwise it returns false. Another example of ADT is QADT. QADT is similar to stack ADT, but the only difference is in the way we store the data. In stack ADT, we store data in last in first out manner, but in QADT, we store data first in first out. Real life example of queue is people standing at a reservation counter. So the first person standing at the queue will be served first, and the last person will be served when all other person in front of him are served. So the functions in QADT are, first is enqueue, which is used to insert an element at the end of the queue. Another function is dequeue, which is used to delete an element from the first of the queue. The size function is almost same, which returns the number of elements in the queue. These two functions are same in QADT, that is empty and is full. This is a diagrammatic view of a queue. New elements are inserted at the end, while deletion takes place at the start of the queue. In the coming videos, we'll be studying the implementation of these ADTs and their code in Python. Thank you.